Hi everyone, in this video we will be going over how to graph inequalities, but first reviewing just how to graph a line in y equals mx plus b. Okay, so we start at our y-intercept, which is -3, so put a dot there. Then our slope, we put that over 1, so it's 2 over 1, which means that it's rise over run, so we're going up 2 over 1, up 2 over 1, and we can connect those. Okay, so for graphing inequalities, there's just a couple more steps that we have to do. Okay, so first of all, just reviewing, this is a less than, greater than, less than or equal to, greater than or equal to. Okay, so for the less than case, we're going to be graphing with a dotted line. Similarly, for greater than, we're going to have a dotted line. Compared to if it's equal to, so if it's less than or equal to, or greater than or equal to, for those we'll have solid lines. So once we're actually doing examples, that'll make more sense. For y equals mx plus b, if it's less than or if it's less than or equal to, we're going to be shading below the line, whether the line is dotted or solid. But if it's greater than or equal to, we're going to be shading above the line. Note that that is only true if the y is by itself. So doing an example, y is greater than 2x minus 3. Okay, so we're going to graph this like normal. We start on the y-axis at -3. Then the slope is 2 over 1, so rise 2, run 1, rise 2, run 1, rise 2, run 1. But in this slide, since we have greater than, okay, so for greater than, we're right here, so we have a dotted line and we're shading above the line. So by dotted line, what I mean is that instead of connecting these dots with a solid boundary line, we're going to connect it with this dashed line. Okay, and then from there we are shading above the line, so at any point on the line we are shading up. So shading up above the line. Okay, so the point is that any place that is darkened makes this inequality true. But the actual boundary line right here, the actual line itself, does not make the inequality true. Only values that are larger than it. So for instance, if we pick any darkened shaded point, such as the point 0, 1, okay, so for the point 0, 1, if you plug 0 in for x, 1 in for y, then that should be a true statement. We should darken all the true statements. So we'll have 1 is greater than 2 times 0 minus 3. So 1 is greater than 2 times 0 is 0. Take away 3, so -3. And we know that that is true, that 1 is greater than -3. My point is just simply that any place that is darkened makes the inequality true. Graphing this one, okay, so graphing it y equals mx plus b like normal. We're going to start at 1, and then slope is -1 over 1, which means negative slope means we go down, so down 1, right 1, down 1, right 1, down 1, right 1. Then our symbol is less than or equal to, so since it's equal to, we'll have a solid boundary line, meaning that the boundary line actually makes it true. Okay, and then since it's less than, we're shading below the boundary line. So we're shading the y values that are less than, or equal to that expression. Okay, so here, graphing it, we're going to graph, so start down 4, slope is 2/3, so up 2 over 3, up 2 over 3. We have equal to, so that's a solid boundary line. Solid boundary line. And less than, which means to shade below the boundary line. So we're shading down here. And any place that is shaded makes the inequality true. And this one? Okay, so here we have actually a system of inequalities. So what it says is we're looking for where both inequalities are true. So to find that, we want to find the intersection of both inequalities. So to find that, we're going to just graph each problem one at a time. So graphing the first one in red, y is greater than x plus 6, so we'll start up 6. Start up 6, and then slope is 1 over 1, so we're going up 1 over 1, up 1 over 1. And that's greater than, so it's not equal to, so we're not going to have a solid line. We're going to have a dotted line. And then greater than means that we're shading above the line. So above the line, right there. The second line is y is less than or equal to negative 1/3 x minus 2. So just rewriting it so we can see it more clearly. And I'm going to start down 2, then the slope is down 1, right 3, down 1, right 3, so up 1, left 3, up 1, left 3, and that's a solid line because it's equal to, so solid line, and we're shading below the line because it's less than, so the y values that are smaller than that, so below the line, shading, okay? Extending out this red region, so that's dotted there, and it's shaded right here. Okay, so what that shows us is that the actual answer is this region which has this solid right here, then following this dotted line right here, and it's the region where both graphs overlap, which is right in here. So our answer to this system of inequalities is this darkened section right there that goes on forever. Any coordinate pair that is in that darkened blue region makes both of the inequalities true at the exact same time. And that's actually the only way to have an answer. So an answer is not going to be just simply like this one-ordered pair like our equations. We're going to have a whole region of that blue region. Alright, so doing another one. Alright, so we're going to graph each one separately and then find where they both overlap. Okay, so graphing the first one, we start up 1. We're going up 4 over 1, because slope is up 4 over 1. Okay, then it's a dotted line because it's not equal to. And we're shading above the dotted line because it's greater than. So shading above the dotted line is that region. Okay, so graphing the other one, we're starting right at the y. So the y-intercept is 0. The slope is negative 2, so down 2 over 1, down 2 over 1. That's a solid line because it's equal to. And we're shading below the line. And we can see the region where both of them will overlap is right in that kind of triangular region. So it has this solid line, a dotted line, and this region over here makes both inequalities true. Last problem, just solving this one where the y is not by itself, so we have to get it by itself first. So we'll add x, draw your line, x's cancel, negative 2y greater than, writing the x first, x plus 1. Then we're going to divide all by negative 2, divide by negative 2, divide by negative 2, divide by negative 2. So dividing by negative 2, we'll get y, and there's a 1 right here, So pulling the negative out, negative 1/2 x, pulling this negative out, minus 1/2. And since we divided by a negative, we have to flip the greater than symbol. So that's from our prior chapter. So we have to flip this and make it less than and actually graph it like that. We're actually graphing y is less than negative 1/2 minus 1/2. So graphing that, we'll start down just 1/2. From there, we're going down 1 over 2, down 1 over 2. Okay, so it is a dashed line because it's not equal to, so the actual boundary line's not darkened. And then we're shading below the line, which is down here. And that whole region are all the values that make that inequality true. See you in class.